So this afternoon, I'm working on a customer's CJ5. It's an 80s CJ5, and it's not a bad little Jeep. My customer bought this Jeep the way it is, and he just bought it to have a Jeep to enjoy and drive around. He's been having constant problems with it, and he's just trying to get it straightened out. Kind of like one of those things that I see frequently here. I don't know if I'm gifted that way or what, but this isn't a bad Jeep, and apparently the guy that built it, I mean, he did a good job. I've looked this thing over. I mean, it's a 80s Jeep. It's not, the frame isn't rusty. It's got a nice glass tub on it. Under the hood is meticulous. It's got a V8 Chevy in it. Nice dual exhaust. You know, whoever put it together was clever. And then apparently it went to a second hand, you know, a second owner. Apparently beat the living snot out of it. And then the customer, well, probably when it wouldn't go anymore, my customer bought it, and it is a cool Jeep. It's just it's been just like hobbled by constant problems, and the AMC Model 20 is unfortunately the culprit, and it was just full of crap. Somebody had just sunk this thing in the mud somewhere. It was just full. And then, of course, the next thing happened is the wheel bearings failed, or the axle bearings failed on the passenger side, particularly. And there's the carnage there, and there was a chunk of metal laying in between, in the cavity in between the big end bearing and the small end bearing when I took it apart. And I've got a picture of that. Maybe we can get it inserted. So I'm just getting down to it. I got a new differential for it, and I'll show you why. We'll go over here. And I've got a backing plate issue that I got to correct. It does have one-piece axles in it. And the wheel bearing failed, the axle bearing failed on the passenger side. And then did it in a big way. So the hole in the backing plate is supposed to be 2 1/4, and this one's wobbled out to about 2 7/16. So there's the gap I'm dealing with. And what happens is with this one-piece axle setup is this all stacks up and makes the bearing work the right way, because it's caught in between to provide the thrust to keep the wheel where it's supposed to be. So this here, you can see, here's the new outer bearing plate, and the bearing and seal plate combined. You can see on this diagram, that right there is that piece, and then that's the backing plate, and then there's the bearing with that little thin ring that holds the bearing together to the inside, and it cheeks up against the inside of the backing plate. So that hole being wobbled out, that hole is all out around, but it's out to about it's a big 2 7/16, just with a pair of dividers or engineered calipers. But that's the 2 1/4, and that's what the hole is now. So I'm worried about not having enough contact here, and especially this is just that little retainer ring that keeps this bearing together as a unit. So I'm going to clean that up. I think I'm going to put it in my medium-sized lathe over there. I'm going to clean this up, sandblast it, weld it in, and I'm going to grab the whole thing. I mean, this isn't precision, but I want to have it so it has material there, so it doesn't just chowder this bearing and causing more problems down the road. I want to renew that diameter to that diameter, basically, and I'm just going to spot weld it in. That's not a big deal with MIG welder. So new differential because of this. So this is an insert, like a Lockrite, that somebody welded because apparently, I don't know, it failed or whatever, and it's broken. Let's see if I can get that to move. Yeah, the weld's broke loose because that's hardened steel. This weld held. And it had a tab of material welded across here and here, and Can't find the tab right now, but that fell out, went through the gears and hucked it through the oil passage that puts the oil onto the pinion bearings. It threw it forward, and it didn't ding up the gears, so that's good. I've got a new differential coming for it. Okay, so we're back to it here. I just dusted this off real quick. I didn't spend a lot of time on it. I hit the area where I got to work the hardest. And there's the pet shop chicken making an appearance. Betty, my shepherd, isn't here today, but she'll probably appear tomorrow. It's getting towards the end of a day. I'm gonna get this cleaned up and we'll rejoin during a little bit of the welding. So the second pass, I'm going to start 180 degrees opposite from where I started the first pass. Just go around again. We'll just take the die grinder real quick like a bunny. Just go around the inside of this. I'm over here at my drive shaft bench because I've got a Millimatic 200 over here with smaller wire in it that I can fill this up pretty good.
One more time.
My dad and my grandfather taught me how to gas weld with coat hangers when I was about 12, and that was all about watching the heat. So basically, if you watch the heat when you weld it, it gives you pretty good control over what you're trying to do. That just basically building this up right on the thickness of the metal. Got a groove going now. I think one more pass, that'll be plenty, and I might just noodle a little cover pass around the outside and the inside. I'm going to grab this in a big 3-jaw chuck and bore the hole. Depending on how flat it is and how flat it is to this surface here, I'll probably face it, or I may just buff it flat. It basically, this surface where I'm right here, not where I'm welding, it needs to be flat, but it's not like a surface plate. Vehicles are like old houses. Yeah, I know. Somebody's gonna say, oh, you should get a new backing plate. Well, I don't have a new backing plate. Don't even know where to get a backing plate for Model 20. Don't want to search for a month. Just gonna weld this up and fix it and get the guy's Jeep done. I got the rest of the parts. They'll be here tomorrow. New differential. We're gonna fix this and just get it back to him. He's gonna be happy as a clam. What I said about watching the heat, it's just basically if you're gas welding or TIG welding or MIG welding, stick welding. MIG welding made everybody think that they're a welder. That's not necessarily the case. It made it easy for people that don't know how to weld, but the fundamentals still apply. And basically what I'm doing here is, this is thin material. I got the heat turned up pretty good. I'm just welding down a little glob, triggering it, letting it cool till it disappears in my helmet lens. When my helmet lens changes back to daylight, I got the delay set about right for this, and so that's literally my timer, and I just am holding, you see that I'm just holding still and I'm moving just down another glob, 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 glob. And that's 100% welded down, and I'm gonna say that that's 2 inches. Oh, yeah, it's down to 1 3/4 inches. So here we go. Bring it up to the camera. So with just that little bit of welding, I got this hole closed up to, hopefully I'm there, 1 3/4 inches. So there's the front side, there's the back side. Hopefully I got it in focus. Yeah, I don't hate it. I think the Cincinnati lathe is gonna grab this puppy right like that. I'll take a little chip on the face. I'll buff out the back or vice versa if I have to. I'm debating whether I want to add a pass, like a cover pass on the top. So, I've got this is the backing plate. I've got it in the 3-jaw chuck. I ran this indicator around it on the exterior with, just by backing it out and on the rim, and it was within about 7, so close enough. And this isn't tool and die work for the next Mars, mission to Mars. This is a brake backing plate for Jeep. So, I got a boring bar in here. This is the Cincinnati lathe that we rescued. I mean, it's all, you know. And I'm beginning to use this old girl more and more. I mean, it's actually doing some jobs. And this is the kind of stuff that I do a lot of. So, you guys can ride along with me. Continue to ride along with me. Hopefully, I get this so that we can stitch it together. So, I got it. I dialed in the face by knocking it around, so I got it running within about 5, and we'll blend it up after. But I'm going to bore the hole to 2 1/4. I've got the seal plate. I'm going to have to run over there and grab it, and a pair of calipers. But we'll see if we can take a cut here. I don't know what I've got for our hands. Taking a 25,000 chip, 25,000 chip, dialing in 25, taking off 50. Just kind of looking it over, and this thing was worn to the top. And it shows it the way that it's taking more off of one side than the other. Because when the bearing failed, the axle went up in the hole and ground around on the top more than the bottom. So I just went and checked the one that is not worn, because obviously I had 2 backing plates. Only one was worn because only one bearing failed. And I just measured like this to the bore of the good one, and the hole is centered in there. So what we're looking at going around is where I welded is to compensate. There's more weld left where the hole was worn out of round to the backing plate. The center line, the true center line, the hole that was worn in the backing plate was not on center anymore. So that's going to be the last area to clean up, and that's what it's showing. This optical illusion makes you want to make double check. We're just going to reach in here with a handy dandy set of engineer calipers, dividers, call them whatever you want. My mentor called them engineer calipers, so that's what I call them. Okay, so we're at 1.950, and we want to be 2 1/4. And this guy here That little seal lip right there passes through that just slightly. And that is right at 2 1/4. So that's what we're going to make this. 2 inches, 122 right now. I got a fairly big radius boring bar. Tool bit in there. The tool bit here has got a pretty big radius on it. Cuts good, a deep cut will cut good, but shallow cut not so much. Shallow cut in a piece of tin that's been welded on. The seal fits in the hole good, and they're showing. Hope it shows up. 2 inches, 251 1/2. I mean, like I said, hopefully that shows. That's showing what the seal size is, so it should be good that way. I'm going to, I think we're going to call it good that, for that, and I'm going to put a facing tool in there. We'll trim that weld out, and then flip it over, and just trim up the weld that's on the back side. But yeah, this is the inside. That's where the bearing's going to hit, and that is the outside where the brakes should go. Okay, so here I've got this the face of it trimmed up, and that shows you the blend line. So you can imagine there's where the wheel cylinder is, so that's on top. And then so this shows this is where it's heavily worn. This is where all of the material, well, not all of it, but a lot of the material. You can see here's the parent metal, and this is where I welded it in. And that's how much it got oblowed. You can see it because this bore is the size that it needs to be now. And that was missing a good, that's right handy to, that's bigger than 1/4. That's more like 5/16 to the edge. And this rim around here, the bottom, once again, this is to the bore. So this is like a 1/16. And so I've got the bearing here. And you can imagine, I've mentioned this, but this is the top because this is where the wheel cylinder is. So the Jeep was pressing down on it. There's the axle passed through here, and when the bearing failed, the Jeep was still pressing down, but the axle was trying to come up because there was no bearing left, and all of the shards of tool steel, the bearing cage, and all the stuff it literally came out in crumbs. So here's the bearing. Let me see. Let me see if I can do this. Here's the bearing. That's the bearing that goes in there. You can see how close it was to being able to pass through the hole. And that's what this is about. This bearing has to have the thickness of this to be correctly assembled and be pinched into the bearing housing the way it's supposed to be, and not be all loose and wobbly. And that's what this is all about. You know, it's like, it's just a backing plate. Well, this is kind of a bizarre situation, the way they did this for these AMC Model 20s, but that's the way they are, and they have to be that way. And that little ring, this little pressed-on ring, they've got that rigged up so that it goes in there, and that's the thing that's taking the brunt. That's how it's assembled. That goes in, and that's cheeked up against this. And the Dana 44s use almost exactly the same bearing and Ford axles, and 8 3/4 Dodges, and the bearing goes the other way. So yeah, so I'm gonna trim that up and then flip it over, and we'll get down to business and get this thing back together. So I've faced this off, and it's out of the lathe, and so here we are. So here's the seal plate, and that little amount right there fits. Oops, sorry. That goes in there. That lines that all up. It's probably gonna fall out, but that shows more on the back side. And then this little reveal. Let's see if I can do that now. I'm not gonna be able to. Yeah, there it is right there. That's how it works. So we're gonna continue on and get the Jeep back together. And I'll have, when I get the differential reassembled with all of its new parts, I'll bring it back in and show you. I haven't got the holes lined up. There they are. Yep. So I'm gonna call this a win and get Jeep back together. Okay, so here we are. We're reassembling the AMC Model 20, and I figured we'd just take a look at the backing plate and how it's orientated and what the big deal is about the hole that I fixed. This is the one I welded in and bored out. So basically, that hole was so worn that this bearing would almost go through it, and if the bearing could actually find its way through it, and this is a drum brake Jeep, so there's no caliper to hold the disc in, the axle would depart the Jeep, and that would be bad. So that's why that needed to be fully supported. You know, I can't send somebody back out on the street with something that's potentially dangerous, so that's good. So that shows it how it all stacks up, and also a little bit illustrates what you're dealing with and why they're kind of funky to deal with, because there's a seal plate underneath, and you got to manipulate all this stuff and get it all pressed back together, and that seal is trapped in there, and that's also makes them hard to deal with, because if the seal goes, you got to take all this back apart again, and you know, all the bearings and stuff, they don't come off easy, so they're all wrecked. So, and speaking of wrecked bearings here, this is probably, it's not probably, it's definitely one of the culprits. This is the inner cage from this bearing that failed on this side. It happened to be the passenger side on this Jeep. So there's just a box full of carnage, and you can see all the grit and everything. I mean, I just took gobs of grit out of this. This is kind of like the carnage pile. So basically, these axle bearings run in grease. They don't run in the lube oil that the differential does, like some axles do. So that's what this is all about. There's a seal in there. I've got that cavity full of grease, because when I assemble it, you know, that the grease that's in there, the grease that you're seeing, is the grease it's going to have unless you disassemble this thing, and they're not easy to take apart. So, you know, that I'm going to make sure that it's got plenty. New true track. I reran the gears, all new bearings, everything's set to 10,000 backlash. Major shim roulette to get the backlash adjusted on this, because the AMC 20 shims are very, very sparse. They give you like 70. They give you two 77,000 shims and two 96,000 shims. So basically that's what you got. So I had to be creative and adapt some from a 10 bolt, which worked out pretty good. Yeah, so this one's all set to go. So here we are, and I'm a little off camera. I'm over here. My sophisticated production value, production quality. I forgot to take the lock bolts out of the seal plates on this one. So, as I was saying, with the backing plates trapped on these axles, the seals are vulnerable because the backing plate's pretty heavy with all the crap on it. So I have it supported. When I was just showing how it was all orientated, I had it sitting on a couple of half-inch sockets so that the backing plate was the backing plate was held up so that the axle was actually going into its real position, so that the seal wasn't all stressed out of shape. So I'm gonna set myself up for success here. This is one of my favorite tools, a snap-on flexible speed wrench ratchet and an extension. I'm gonna put the nut in it and hopefully drop it. So my goal is I'm gonna just try and grab all that and support the backing plate, not wobble it around a lot, and just kind of all in one motion go. I did the other side already, and that worked, but the camera wasn't on. Phone. So here we go. We're gonna try get this. That's the nut that I had holding the backing plate on overnight. I had it glued together. Gotta catch the spline inside the true track. There we go. Now I'm gonna hold the backing plate up. Good, that's in there. Spin this around and find one of the holes. I hit my ratchet set on loose there. That's pretty good. Come around here, I'll do the opposite one. The top right side. And I got the light on, just about blinding myself on the stand. James Cameron, I'm not. Yeah, good. She took a bite. I'm gonna grab this. Yeah, Jeep's got a fiberglass tub. Guess what? Magnet light ain't gonna work very good there. These are fine thread, and you got a handy dandy electric ratchet, but them things, they can surge a bolt onto a nut. I mean, a nut onto a bolt, and fine thread. I don't want to bung one of them up on Friday afternoon, that's for damn sure. I can take an extra 30 seconds and do them with a speed wrench where I've got a little bit more control. And I won't be pouty if when I bung up a nut, because I'm not gonna. That one's turning on the back side. Oh, that's weird, because those, look, usually those are T-bolts. That one's not. Okay. I got all four of them started here. Go opposite again. That one's pretty tight. Spinning. Oh, yeah, it is now. Alright, so that's pretty much going to wrap this up. I've got put the rear cover on it. I got to put the nuts on the other side and put the brake drums on, adjust the brakes. I got to hook the brake lines back up and bleed them, and yeah, just finish this up, get it back to the customer on Monday, and then let's see what's next. I got an 8 3/4 Dodge. I got to do an 8 3/4 center section just left, and that's video 254, I think, on my YouTube channel. So hopefully some of you guys see that. And then I got an 8.8 and a 9-inch Ford that both need to be narrowed. So, and I'll try and do some more machine work. Although the reason why I don't see that much, I get rushing around and don't take the time to do this, and it does take some time. But I thank everybody for watching, and I've got a lot of new viewers, a lot of new subscribers, and I thank all of you for that, and the people that can manage to hit like. Try and hit like. That does make a difference, and trying to just do a little bit of this. I don't think I'm going to be making many major movies, but I do this stuff every day for the last 39 years, so it's kind of fun. I still enjoy what I do. Just turned 63, and I'm going to go for a long time yet to come, I hope. Thanks for watching.